Right, so here are the remaining questions. From a point P, tangent is drawn to the circle, and the tangent is drawn to this circle. If these tangents are perpendicular, then the locus of P is. Alright, so these are perpendicular. Fine. Just draw this out. Okay, so these are the two circles. This is A, right? This is the one with radius A, this is the one with radius B. From a point P, okay, so this is the point P. Tangents are drawn to these two circles. Okay, so this is the first tangent, and these tangents must be perpendicular. This is very bad. Okay, this is the first tangent, and got this thing. You know, this angle is 90 degrees, which means it cannot be this one, right? It's not this tangent because these can never have the difference of angles as 90 degrees, right? So it has to be this tangent which we are looking for. I know it doesn't look like this angle is 90 degrees, but we'll just assume it is actually 90 degrees. So then what do we know? If this is 90 degrees, okay, then this is also 90 degrees, and this is, right, this length is B, and this length is A, right? And what do we have over here? Oh, this is 90 degree, this is a 90 degree, this is also 90 degree, which means this also has to be 90 degrees, which basically means this has to be a rectangle. So this is A and this complete thing is B. So that means this length is A squared plus B squared, but the square root of that. So x squared plus y squared equal to A squared plus B squared, right? That should be the locus. Where were we? Here. Okay. For 35th question is, a circle is inscribed in an equilateral triangle of side 6. Find the area of any square inscribed in the circle. Oh, that's weird. Okay, so let's just draw an equilateral triangle, and there's a circle inscribed inside this, and this has side 6. Okay, so hey, wait a second, why do even we do all that? What's the area of that equilateral triangle? Oops. The area of that equilateral triangle is square root of 3 by 4 into side squared, which is 6 squared over here. But it should also be the semi-perimeter times the in radius, right? Yeah, that's also the area of the triangle. So semi-perimeter is 6 plus 6 plus 6 upon 2, which is 9. So it's 9 into the in radius. So that means square root of 3 into 9 equal to 9 into r. So r is square root of 3. Nice. Okay, next we have to find area of any square inscribed in that circle. So the diameter of that circle, which is 2 square root 3, that is the diagonal, isn't it? Which is also like square root of 2 times the side of that square. So the side is 2 square root of 3 by 2. Nice. So side squared, that's just 4 into 3 by 2, which is 6. So 6 should be the area. Nice. Next question. The tangent at any point to the circle meets the coordinate axis. The circle x squared plus y squared equal to r squared meets the coordinate axis at A and B if lines drawn parallel to the coordinate axis through A and B intersect at P. Then the locus of P is. Okay. Oh, let's try it out. I think I've done these kind of questions once, so let's just see if I've retained that memory. Suppose this is, oh shit, this is not a circle. Draw a better circle. Why can't I just draw a circle? Yeah, this is a circle. Okay, so suppose this is the circle which we are interested in. It has radius r, and we take a point from which we draw this tangent stuff. Okay, and this meets the coordinate axis at A and B. Nice. And if a lines drawn parallel to the coordinate axis through A and B intersected P. So something like this. One good thing about coordinate axis is there are a lot of 90 degrees everywhere. Okay, just deal with this. So this point is P. Let's just say this length, I don't think it should be length. This is X and this is Y, correct? Maybe I should say this is mod X and mod Y, right? That would be better. So the area of his complete rectangle, OBPA, that thing is going to be mod X times mod Y. But this length is obviously square root of x squared plus y squared, and this length, which is perpendicular to this BA thing, that thing is r, right? So this should also be half into okay, so 2 into half into r into square root of x squared plus y squared. So this cancels. So let's just square that. So we should get x squared y squared is r squared into x squared plus y squared, which means 1 upon r squared equal to 1 upon x squared plus 1 upon y squared, and that is this option. Next question. If a cosine theta I for I being 1 to 3 represents the vertices of an equilateral triangle inscribed in a circle, then okay, so it's like this is the circle and then you got something like a triangle and these points, these are these a cosine theta I and a sine theta I stuff, right? You know what, this looks more like a physics problem rather than a maths problem, because if we draw these vectors, these position vectors, right, and then we just add these position vectors, their resultant has to be 0, right? We have done this a lot in physics, which means cosine theta I plus cosine theta 2 plus cosine theta 3 has to be 0, because the x component of position vector, the resultant position vector, that thing is also 0, correct? Position vector, I should just say vector, yeah, whatever. Let's just move on. Is there sine theta stuff? Oh, it's not equal to 0, right? Then this is not going to be correct. So A is only correct and B is not, and no, C and D are also not correct. 38. Of the two concentric circles, the smaller one has equation x squared plus y squared equal to 4. Okay, so let's just draw this out. This is the smaller one, x squared plus y squared equal to 4. It has radius 2. If each of the two intercepts on the line x plus y equal to 2. Okay, so now we also need to graph everything. That's not what I want. Okay, let's just deal with that. Right, so this line is x equal to 3, right? No, not x equal to 3. Oh, wait. We don't need to graph this. We just need to find the perpendicular distance from the center to that line, because we are not asked. First of all, we are asked about the radius of the bigger one, and then we can just find the locus, right? Locus, find the equation of that circle. So x plus y equal to 2. If I put 0, 0 into that, this should be 2, right? The mod of -2 upon square root of 1 plus 1. So that is square root of 2. That is the distance from this line. Correct. Which is smaller than 2. So this is the line which we are interested in. This distance is square root 2. This is 2. And then we have a bigger circle. Okay. Whose radius we don't know, let's just say it is r. This doesn't fit in place, but whatever. Let's just say this radius is r. small r. Then then what do we know? Oh, we are also given the intercept, right? Okay. If each of the two intercepts on a line made between the two circles, okay, between is 1, the equation of the larger circles, right? So this length is 1, that's what they mean. What's this length? It's square root of 2, right? So what's r going to be? R is going to be like r squared is square root of 2 squared, which is 2, plus square root of 2 plus 1 squared, which is 3 plus 2 square root of 2, which is like 5 plus 2 square root of 2. Yeah, so r is square root of 5 plus 2 square root of 2. That is okay, I guess, right? So 2 square root 2 plus 3, right? It's not going to be anything better. Okay, fine. So now we know the radius of this bigger circle. Let's just find its equation. So because it's centered at 0 comma 0, x squared plus y squared is r squared, which is 5 plus 2 square root 2. Hey, this was easy. So yeah, B should be the correct answer. 39. A point on the line x equal to 3 from which tangents drawn to the circle x squared plus y squared equal to 8 are at right angles. Oh, okay, I got it. So this is the circle, okay, and this is the line x equal to 3. This has radius 2 square root 2. Okay, so this has radius, hey, yeah, 2 square root 2 is less than 3, correct? So 2 square root of 2. What else? And we take a random point from which from which when tangents are drawn, those are at right angles. Oh, that means it sits on the director circle, which means its distance from the center, that should be square root of 2 times the radius. So square root of 2 times 2 square root 2 is 4. So this distance should be 4. This distance is 3, which means this distance has to be what is it? It's square root of 16 minus 9, which is, I think it's 7. So square root of 7. So this thing is square root of 7. But this could also be this one. So like this is square root of 7 as well. So we can have 3 and plus or minus square root of 7. Is it there? Oh, so this is a point, right? So it has to be at least one of those points, not exactly both of those. Next question. If the equation of the incircle of an equator triangle is x squared plus y squared plus 4x minus 6y plus 4 equal to 0, then the equation of the circumcircle, oh, okay, cool, right? So just write this in the form which we require. So x plus 2 squared plus y minus 3 squared is, so 4 minus 4 is 0, so it's 9. So radius is 3. Okay, that's the most important thing. Radius is 3. So let's draw that triangle. This incircle, it has radius 3, and then this bigger circumcircle, I don't know what radius it has, right? But we know that this is the radius and this angle is 30 degrees, right? Sine of 30 degrees is 3, so this radius actually has to be 6, right? So just instead of 9 over here, you will have 36. So x plus 2 squared plus y minus 3 squared equal to 6 squared, which is 36. That's going to be the equation which we need. So that means x squared plus 4x plus 4 plus y squared minus 6x plus 9 equal to 36. So x squared plus y squared, it's y over there, plus 4x minus 6y. 4 plus 9, 13. 13 minus 36 is 26 minus 3, right? So minus 20, minus 23. Yes. equal to 0. Is that in the options? So we want plus 4x and minus 6y. B is in the options. Okay, the angle between 41 is the angle between tangents drawn from a point P to the circle is 60 degree. Okay, then locus of P. Oh, come on. Okay, locus of P is going to be another circle, and we can find the radius of that circle. So this is x plus 2 squared plus y minus 1 squared is equal to, so it's 4 plus 1, which is 9, right? That means the radius is 3. So this is the circle. Angle between the tangents drawn from point P, and suppose these are the tangents. Right, these are 60 degrees, and this is 90, this is 90. So this has to be, I think it has to be like, these two have to be 180, right? So 120 degrees, correct? And what's the radius? It's 3, right? So we just need to find what this thing is, that's all. So this is going to be 60 degrees and this is going to be 30 degrees. So it's a classic 30, 60, 90 triangle. So cosine of 60 degrees is 1/2, which means that this thing should be 6. Cool. So instead of 9 over here, you will just have 36. Hey, it's the same as the last one. So x squared plus 4x plus 4 plus y squared minus 2y plus 1 equal to 36, which means x squared plus y squared plus 4x minus 2y. Hey, 4 plus 1 is 5, so 5 minus 36 is minus 31 equal to 0. Is that in the options? Yes, it is. It's A. Nice. And last 2 questions. Let's just do them fast. Okay. The radius of the larger circle is, oh, that's nice. So they gave a diagram. Okay, a circle with center A and radius 7 is tangent. This radius is 7. Should just make them a little less. This radius is 7. Is tangent to the sides of an angle of 60 degrees. A larger circle with center B is tangent to the sides of the angles and to the first circle. Radius of that circle. Oh, come on, this is very easy. This is fairly easy, right? So I should just maybe minimize this. So this thing is 7. This thing is also 7. We are interested in this thing. This angle is 30 degrees, right? 30 degrees. What is this? This is also 7, right? This is 7. So we want to know what this length should be, maybe. Yeah. Okay, what are we going to do? How are we going to find this? Okay, we know this is not gonna work. You know what? It would be better if I just assign some variable to this quantity. Let's call this as x. Okay, so this is x and this is 7, and say this is r, and this thing is also r. This thing is 30 degrees, right? Sine 30 degrees is 1/2. So because this complete thing is oh, that was, this is not 7, this is r, right? This is r. It's like r plus 7 plus x is equal to 2r. Nice. And over here this thing is 7, so 2 times of 7 is like 14, is x plus r, sorry, x plus 7. Yes, which means x is 7. So this is 7 over here. 7 plus 7 is 14. So r is 14. Oh, that was easy, right? So radius is 14. Hey, but why didn't you put that over there? 2r is r plus 7 plus x. Yeah. Oh no, shit. So 14 is x. It's not 7 plus x because we made this distance to be x, right? Yeah. So r plus 21 equals to 2r. So like r has to be 21. Nice. So B is correct. Last question. Two circles are having centers and radii B and C respectively. Then the points of contact of the common tangents to the two circles lie on. Two circles are having centers a comma 0 and minus a comma 0. Just say this. This is very. I should have a bigger one. Okay, centers a comma 0 and minus a comma 0 and radii B and C respectively. A is bigger than B is bigger than C. Then the points of contact of the common tangent. Okay, so A is bigger than both B and C. Fine. It is B and C respectively. Then the points of contact of the common tangents to the two circles lie on. Okay, I guess they should be lying on another circle looking from the options. So they must be like concyclic or something. So just say this is our 0, this is our origin. So this is like minus a comma 0, this point is a comma 0. Then you got two circles, right? This is the first circle and B is bigger than A, so this circle is much bigger than the other circle. Okay, and we want to find the points of contact of the common tangents of the lie on. Right, so let's just deal with this thing. These are the common tangents. Points of contact of the common tangents with a circle lie on, and these can also be the common tangents. Do we know anything else? So you got a 90 degrees over there, right? This is a 90 degree. Yeah, it does look like these will be concyclic. Yes, it does look like these will be concyclic. First of all, these are like parallel, which definitely means these are 90 degrees, and then these angles are equal. Yes, these will be concyclic, that's for sure. But where will the center lie? It has to lie on this axis, the x-axis, but just where? Oh, come on, why is this so hard all of a sudden? Okay, this is a 90 degree, that is also 90 degree, that is a 90 degree, and that's also 90 degree. Come on, why is my brain not working suddenly? You know what, actually this is such a good question, maybe we can keep it for later. But okay, you know what, instead of spending so much of time, let's just go for special cases instead. So let's say maybe when A is, say, A is equal to B equal to C, at that point the points of contact, right, so it should be like, yeah, they are going to be like on this rectangle stuff. Yes, which has 0 comma 0 as its center, and this thing as the diameter of something, right? So like this is length A, this is length A, so this should be square root of 2A, that's the radius. That will be like x squared plus y squared equal to A squared, something like that. That is if A equal to B equal to C. So this one is obviously not correct because this doesn't look like it's gonna happen. Oh wait, maybe this is correct, I don't know. if a equals to b equals to c, okay, it can be anything. uh, Even if b equals to c, if just b equals to c, then this thing is this is b and this is a, so this is like square root of a squared plus b squared, right? That's the radius. So x squared plus y squared equals to a squared plus b squared if b equals to c, right? Which means this is not correct, and similarly this is not correct, so a should be the correct one, because it's gonna be giving us that result which we want, right? It has to be like 2a squared b, something like that. Okay, that's done. That is done. What if these will be like 0? If these are 0, then it just has to be a squared, right? Then it has to be x squared plus y squared is this b squared or what? So that minus a comma 0. Hey, that radius is not necessarily b. Okay, this radius is b and this distance is a. Sorry, it was opposite. Fine. Yeah, for that too is it's gonna work. So this is a nice question. I will be trying to prove it the next time, but for now we just did some special cases and this is the answer we got. Okay, I will see you the next time.